Hello and welcome to episode 2 of Science After Hours. In this particular lecture we are going to dive into one of the most important items a player might have in their inventory when playing a Final Fantasy game. And that is the Phoenix Down. I'm sure if you've played any Final Fantasy game you are aware of what the Phoenix Down is. It's a selection of Phoenix Downs from across the Final Fantasy franchise. It's a magical item that can bring a party member back from a knocked out state and gets them back into the fight in the heat of battle. But is there any scientific merit at all across the many different Final Fantasy worlds? Or perhaps even in the real world, is there some sort of scientific merit to the Phoenix Down? Well, let us find out together. One must go all the way back to Final Fantasy XII to find the potential origin of the Phoenix Down. It is worth mentioning that the different numbered Final Fantasy games are sort of separate universes. There are common themes between them all, but the world of Final Fantasy XII is different from that of Final Fantasy I, Final Fantasy VII, Final Fantasy X, 13, 15, 16, the next Final Fantasy 17, it'll be a different world. But in the world of Final Fantasy XII, we can find the origins of the Phoenix Down in one of the Alatat runes, additional bits of information that are gained from defeating certain enemies. So if the enemy Twintania is defeated, then we can learn a tiny bit more about the Phoenix Down. And this comes from Kirik the Pugilist, and he says the undying phoenix is said to call back souls from the heavens. To win the attention of such a fabled bird, you must give up a feather as an offering. The best are the downy feathers of the tail, hence the term Phoenix Down. See, mark well that not just any feather will do. Depending on the quality and size, the blessing varies greatly. Displeased, you get what you pay for. So, he's mentioned down feathers, but what are down feathers? Well, birds have multiple layers of feathers, as you might imagine, and this figure here shows us some of the more common types. The flight feathers, those feathers that you might find on the ground when you're out for a stroll, but it is these feathers here, the downy feathers, that we are interested in here, the Phoenix Down. So the down feathers are a layer of smaller, finer feathers that are found below the tougher exterior feathers of the bird. And these feathers don't aid in flight in any particular way. Instead, they act to insulate the core of the bird. And so birds that migrate vast distances across the world and undergo quite drastic changes in their temperature over the course of an annual year often find themselves having a larger, more compact layer of downy feathers to help keep them warm. Additionally, water birds are often found to have more downy feathers than your average air-based bird, and that's because downy feathers help to keep the bird buoyant when it is floating in the water. So from this brief introduction to feathers, one can extrapolate that the Phoenix Down is the innermost layer of feathers found on a phoenix. Now, I'm sure you're all well aware of what a phoenix is in the most general of terms, as it is one of the most well-known mythical creatures, but just in case you don't, I'll give you a little brief introduction. And this here is the phoenix from Final Fantasy VII. You can see it to be red bird, as you might have imagined. But in ancient Greek mythology, the phoenix was a bird that was able to live, in some descriptions, up to and over 1400 years. But the important part is when this bird dies, it becomes reborn into its own ashes. There are a lot of Harry Potter fans in the world. I'm sure folks will remember seeing such a similar scene in one of the Harry Potter films. So you can extrapolate that the feathers from this immortal bird may have some sort of healing qualities. And that brings us back to Final Fantasy. So, as I said earlier, using a Phoenix Down will revive someone from the knockout status, which is great in battle, but there is debate as to whether a Phoenix Down actually brings somebody back from the dead. Sure, we have that item description from Final Fantasy XII and Kirik the Pugilist that mentions returning souls to bodies and whatnot. And in some of the Final Fantasy games, a Phoenix Down can be used as a weapon to defeat enemies of the undead, so a zombie, a ghost. So that would strongly suggest that, yes, Phoenix Downs are bringing people back to life. However, a crucial scene in Final Fantasy V tells us that this isn't often the case. One of your party members in Final Fantasy V is the warrior Galuf, who joins the party to help defeat the antagonist Exdeath. Spoilers for Final Fantasy V, which is an incredibly old game now, but Galuf helps defeat Exdeath earlier in his life and helps seal him away. However, in this particular battle between the two, it is Exdeath who is the victor. Unfortunately, Galuf passes away, and as we are about to see, the rest of the party members attempt to use various potions and the magic spell Raise, which has a similar effect to a Phoenix Down. But importantly, for this particular video, they also use a Phoenix Down. So let us quickly take a look at this vital scene from Final Fantasy V. So there, as you can see, as I said, they attempted to use a Phoenix Down to revive Galuf and were unsuccessful. An interesting theory I found online is that the Phoenix Down only works if there is a body that can possibly be restored. So this here is the attack Ultima, as shown in Final Fantasy XIII, but is present in many Final Fantasy games. And this, I would argue, is a body-destroying attack. I mean, the player character Lightning is somewhere in here in the midst of this explosion, and we can't even see her. However, should Lightning go down after exposed to Ultima, she can still be revived with a Phoenix Down. Whereas this theory I found online would dictate that if Lightning or Cloud or whoever was destroyed by some sort of predator missile or something and his body was absolutely ruined, a Phoenix Down would not work. And yet Lightning here can be revived with a Phoenix Down. Another thing that would suggest that this theory is not entirely watertight is that Aerith in Final Fantasy VII gets stabbed with a sword. Now, a sword injury, whilst she sadly dies, spoilers for Final Fantasy VII, I guess, that a Phoenix Down could be used to revive her. However, that is not the case, and so maybe it's best not to think about the logistics of the Phoenix Down too much. And then maybe on that note, it is time to move on to the real world. And what a real world equivalent of the Phoenix Down might possibly considered to be is the defibrillator. But before we even talk about restoring heart function, we should briefly touch on what is involved in a heartbeat. So here we have a figure of the heart, and the heart is made up of 4 chambers: the left and right atria on the top and the left and right ventricles on the bottom. So deoxygenated blood from the body, from the upper body, comes from the superior, and the rest of the body, the inferior vena cava, and that enters the right atrium here. And an electrical impulse from the sinoatrial node causes the atria to contract, and a change in pressure that opens this tricuspid valve here, and blood flows from the atria into the ventricle. A second electrical impulse from the avioventricular node travels, so the avioventricular node is somewhere around here. It travels down the Purkinje fibers, which are something you could imagine here, and they go across the myocardial tissue and cause the ventricles to contract, importantly from the bottom up. So the entire ventricle is emptied and the deoxygenated blood leaves the heart through the pulmonary valve and then into the pulmonary artery to go to the lungs to be refilled with oxygen. So at the very same time, the left atrium is being filled up from the pulmonary veins with blood that has already been reoxygenated from the lungs. It's coming back from the lungs and into the heart. And that same electrical impulse from the sinoatrial node that's causing the right atria to contract causes the left atria to contract. And this oxygenated blood enters the left ventricle, and when the ventricles contract, this oxygenated blood goes up and out through the aorta and to the rest of the body, oxygenating all the cells and tissues that require it. Our fingers, our brains, our heart, our lungs, everywhere else that requires oxygen is getting their oxygenated blood ultimately from this left side of the heart. So when your heart stops and there's no blood pumping around the body, that's obviously quite bad for you. And so a defibrillator, I'm sure if you've seen any medical drama, you'll be aware of what a defibrillator can be used. A defibrillator is sort of two metal paddles that, when placed in appropriate positions on the body, will deliver an electrical impulse that will hopefully restart your heart. This is what defibrillators look like these days. There are two types, monophasic and biphasic, and that's based on the direction the electricity flows through the paddles. Most defibrillators these days are biphasic, so there are two electrical impulses going either way, so allow more of the heart to be covered by the shock. However, how this large electrical impulse that is delivered to the heart can restore its function isn't particularly well understood. So at the basic level, this strong shock resets the heartbeat, giving time for the heart to reset itself back into the rhythm of the node-to-node electrical signals and the contractions that come with those. The theory is that this strong voltage excites, depolarizes, and then stuns a large proportion of the cardiac tissue, overcoming any potential arrhythmias or irregular heartbeats that the heart may be suffering as it fails. This stunned state gives time for the heart to sort of reset, so you can imagine that using a defibrillator is basically a big biological fancy case of turning it off and then turning it back on again, and then normal function is restored as dictated by this smiley face here. But the lack of understanding lies in how this electrical current is actually moving through the cells, those cardiomyocytes. So if the heart was made up of a single cell, as shown here in this figure, when the defibrillator creates a current from the positive to the negative, the electricity will travel down this gradient. And when it comes into contact with this cell, there'll be a voltage differential, the VM, the membrane voltage, which is the intracellular voltage subtracted from the extracellular voltage here. The cell membrane acts as quite a strong barrier against an electrical impulse, so not much of the strong electric shock actually enters the cell. Most of it just sort of cascades down and across the cell membrane, keeping the cell intact and its functions, normal functions, safe and secure. So if you were to scale that up into a multicellular organism, a multicellular heart like we have, you might expect that the same theory to apply. That you get the positive electrode, the electricity travels down to the negative electrode, and then there is this membrane potential between the two. And that results in the cable theory, which is shown in the top part of this figure here. But the issue with that theory is that those areas closest to the positive electrode would receive the strongest shock, and those areas furthest from the electrode would receive a very weak shock or no shock at all, as shown here by the higher membrane potential along the larger distance. But we don't see that. We don't see that at all. In fact, what we see here is a combination of the sawtooth model, which is this sort of spiky line here, and the cable model, into a combination of the two. So the sawtooth model is sort of where the confusion lies. Yes, you get the stronger shock from nearer the electrode. As the distance travels from that, the shock gets weaker. But you also get these virtual electrodes, which are not real electrodes, that are firing off electrical signals throughout the heart tissue, causing this sort of spiky response here, keeping the strong electrical shock constant across the whole heart tissue. What causes these secondary electrodes, these virtual electrodes, is unknown. Nobody knows. There are theories that suggest that it could be to do with the junctions that hold the cardiomyocytes together, that different junctions can offer different resistances to the electrical impulse, and so some that offer a greater resistance will slow the impulse down, that some offer reduced resistance, the impulse will go further and faster, so all these slowed and sped up electrical impulses are then going off at different times. A related theory to that is it's not to do with the individual junctions between the cells, but rather the overall structure of the heart itself. So the amount of muscle you might have, the amount of adipose or fat tissue you might have around your heart will dictate the resistances, and so the speed at which the current of the shocks travels through the heart, and they may result in these virtual electrodes, that those slowed right down electrical impulses are sort of brought to a stop, then they build up and release their charge at a separate point to the main impulse from your positive defibrillator. But as I say, at the moment nobody knows, and it's currently an area of active research. So maybe one day there'll be a follow-up to this video here that will offer a greater explanation as to how defibrillators work, but at this moment in time that's not right now. So I thank you for listening to this lecture, for learning a little bit about the heart, and maybe far too much about the Phoenix Down and Final Fantasy. Thank you for listening.